talk about computers, people's iPods, MP3 players, everything is running on electricity. We're really moving more and more to an electrical economy, not only in our daily lives, but also in manufacturing. And as we do that, nuclear energy needs to play a very key role in that policy. I'm not an expert in climate change, but what I always tell people that if you are concerned about climate change and global warming, you have to support nuclear energy.
Nuclear energy produces electricity without any greenhouse gases. It is safe. Over the years, nuclear operators have learned how to operate nuclear power plants without danger of difficulty.
I think if you talk to most people and you ask what is their biggest concerns about nuclear energy, the first one will be safety. The next one will be, what are you going to do with the waste?
I view that actually as the Achilles heel of nuclear energy. We think it can be dealt with in a very sensible way. The previous way of dealing with it, stick it in the ground at Yucca Mountain, makes no sense to me because it's full of energy, and to throw that energy away because you didn't know what else to do with it doesn't make an awful lot of economic sense. We think through reprocessing, which this government unfortunately stopped 30 years ago, we can actually extract that energy, reduce the toxicity and heat load by at least a factor of 100, leaving behind waste which is easily dealt with. Now this takes science, it takes policy, it takes a commitment on the part of our government, but we think it's doable.
The public, both in the United States and in other countries, would like to see a permanent solution for the spent fuel issue. Therefore, it's very important for the University of Texas at the Energy Institute to look at what are the things that we can do on a national and global scale to solve some of the energy problems that we're faced with. In most of the ways that we generate electricity, we turn water into steam. All a nuclear reactor does is boils a lot of hot water. And so the way the heat is generated is by the fissioning of an atom of uranium-235. And when that atom is split, mass is turned into energy, and that's what generates the heat to basically make hot water, and then the hot water turns into steam, steam turns into turbine, and electricity is generated.
This little black thing here is a simulated uranium fuel pellet. This little pellet right here provides the same amount of energy as a railroad car of coal, about a ton of coal, or about 160 gallons of gasoline, right, from this pellet. And the 104 nuclear reactors we have in this country are all fueled by pellets like this. Spent fuel is comprised of these things, right? And we've generated so far, the nuclear industry, about 50,000 tons, metric tons of spent fuel. If you took the 50,000 tons of spent fuel we've generated till now and you stacked it in the UT football stadium, right, from end zone to end zone, it would make a stack 6 yards deep. So there's incredible energy density in this stuff.
The challenge I think that we have in nuclear waste disposal is letting people understand that there's not a crisis, it's not a safety or security issue today, but it is an issue that we need as a nation to determine what is our long-term strategy for high-level waste disposal. We are the only country, the only major nuclear country, that does not recycle spent nuclear fuel. We want to look at our faculty and students, have them develop programs where they can look at research opportunities, help develop the technologies that will make a better option for recycling. One of the advantages that the University of Texas has is that we have the newest university research reactor in the United States. The reactor went into operation in 1992. It really makes a great teaching and research tool. So as we look at new technologies for nuclear applications, the Nuclear Engineering Teaching Laboratory can play a key role in both education and research for the future generations.
So I'm Steve Bogalski. I'm the director of this facility, which is the Nuclear Engineering Teaching Laboratory. Within our facility, we do both research as well as conduct education and teach classes here at the facility. We do not produce electrical power, but we produce neutrons. And largely what we're doing with those neutrons is irradiating samples, using neutrons for various nuclear analytical techniques, for analysis of materials, imaging, etc. We also use the reactor a lot for training. So we have had a research reactor within Austin for 40+ years. And this reactor facility has been here for almost 20 years. And so we have operated in a very safe manner in that time period without it having any real problems. We do conduct very useful research, everything along the lines from medical applications, environmental studies, nuclear nonproliferation research to development of next generation nuclear power technology. And as a result of such, the benefits for this facility have been tremendous over the number of years. From a reprocessing perspective, we have a lot of capabilities here. Everything from imaging that might be used at looking at spent nuclear fuel to actual wet chemistry.
Ultimately, the disposal of the spent fuel and whether or not recycle really needs to be a partnership between industry and the government. As Dr. Orbach has said several times, the Energy Institute is good policy based on good science. We'd like to see the Energy Institute being very involved in good science to help drive good policy for the management of spent fuel.